Today's lesson we are going to be talking about graphing exponential growth functions. As you can imagine, a growth function is going to go up, which because you're growing from a beginning point to an end. So it's going to be in an upward motion. The first thing we need to talk about is some of the vocabulary that you might see. The first thing is the exponential function itself. You're going to see it in the form of y equals ab to the x power, where your a doesn't equal 0 and that the base b is any positive number other than 1. The next one is the exponential growth function. And again, it's a function in the form of y equals ab to the x power, where a doesn't equal 0 and b is greater than 1. So there is a little bit of a difference. And then the growth factor. In your y equals a to the b x power, b is the growth factor. And then the asymptote is a line that a graph approaches more and more closely. I can say that with this, it's something that has been used more and more over the last few years. What it means is that your graphed line is going to get really, really close to a number, but it never touches it. That's what this really means. And that's what I will say is, where does the line get close to but never touch? And then we have a parent function. In this y equals ab to the x power, the parent function is going to be y equals b to the x power, where b is greater than 1. For this, the domain will be all real numbers, and the range will be y is greater than or equal to 0. And that will give you some information as we start working the problems in this lesson. The first graph we want to look at is to graph y equals ab to the x power for b is greater than 1. And so I've chosen graph y equals 1/4 times 6 to the x power. So the first thing you want to do is you want to make your xy table. And so I'm going to do that. My xy. And I'm going to choose to use 0, 1, and 2. So what I'm going to do is I've got to plug in my x that I chose into the equation. So I'm going to do that here. I've got y equals 1/4 times 6 to the 0 power. Anything to the 0 power is 1. And so this becomes 1/4 times 1, which is equal to 1/4. Again, I've got y equals 1/4 times 6 to the first power. Anything to the first power is itself. And so I can say this is 1/4 times 6 over 1, because any whole number can be made into a fraction by putting it over 1. So I can now say 6 over 4, which I can reduce down. And when I divide 6 by 2, I can get 3. When I divide 4 by 2, I get 2. So my answer is 3/2. And then my last one, y equals 1/4 times 6 squared. That gives me 1/4, and 6 times 6 gives me 36. And so again, I can put 36, I can rewrite it as 36 over 1. And so that gives me 36 over 4. And then if I divide both top and bottom by 4, 36 divided by 4 is 9. And 4 divided by 4 is 1. And so my answer is 9. Once I have that, I'm going to come over and I'm going to go ahead and graph it. I have 0 and up 1/4. So it's going to be about right there. And then I have 1 and 3/2, which is 1.5. So I'm going to go about right there. And then it goes 2 up to 9, which is right there. And so now I have to connect my plotted points. And so it's going to look similar to this. And that is the graph of y equals 1/4 times 6 to the x power. The next graph I want to look at is y equals ab to the x minus h power plus k when b is greater than 1. So again, I chose to graph y equals 2 times 3 to the x plus 2 power minus 1. And then we're going to state the domain and range. On this one, what I want to do is I want to graph my parent function. My parent function is going to be 2 times, and I'll put parent function, and that is y equals 2 times 3 to the x power. So, graphing this, I'm going to go ahead and make my XY table. XY. And this time, I'm going to use 1, 2, and 3. So again, what I want to do is I want to solve my parent function. So I want to say y equals 2 times 3 to the first power. Again, everything to the first power is going to be itself. So I can say this is 2 times 3, which gives me 6. Again, I want to solve it. This time I want 2 times 3 to the second power. 3 times itself, 3 times 3 gives us 9, so 2 times 9 gives us 18. And then my last one is cubed to the third, so 2 times 3 cubed. And again, 3 times 3 we found was 9, times 3 gives us 27, and so that's going to give us 54. Now, I'm going to graph this, but I'm going to graph it in 2 colors so you can see my parent function and then how we change it. So the first thing I want to do is I'm going to come over here and I'm going to graph the numbers that I have. This time, because you can see that my numbers are so great, they jump drastically, what I'm going to do over here is I want to count by 3s. My y's are going to count by 3, so I'm going to put y's count by 3s, and then my x's count by 1. That way, if anybody was to ever look at my work, they would be able to know why my graph looks like it does. So now I want to go ahead and graph. I need 1 and 6. So I'm going to go over my 1, but remember, because I'm counting by 2s, I'm counting by 3s, I'm only going to go up 2. Now I have 2 and 18. So I'm going to go over 2, and this time 18 divided by 3, that means I actually move up 6. And then by counting by 3s, I move over 3, but then when I divide 54 by 3, that's still going to give me more than what I have. So I'm going to have to say up 3, and I'm going to go approximately up higher to maybe about that point. Because when you do 54 divided by 3, that gives you 16. And I have 10 spots, but I need it even higher. So now what I want to do is I want to connect my dots. And so I'm going to start, and I'm going to go this way. But you can see that it's almost a drastic improvement. I go up at such a quick rate, and it's going to go that way. Now, that is my parent function. So I want to put parent function. Again, that is for anybody else to know because they're going to see two different graphs. What I'm going to do now is I'm going to change to blue. And what you do, once you use your parent function, you go back up here and you see a positive 2 and a negative 1. Originally, it should have been a negative number and then a positive number. So what I can do, and right above this, I'm going to rewrite this as 2 times 3 to the x minus a negative 2 plus a negative 1. That way you can see my minus h, so it's a minus a number, and then plus a number, which is plus k. Now, what you do at this point is what's attached to the x. So your h is how you move left or right. And because I'm doing a negative 2, I have to move my points over 2. And then this one, your k, is your y, and so you move down 1. So I'm going to move over 2, and I'm moving down 1. On this one right here, I'm moving over 2, down 1. And then this one, I moved over 2, which would have been 1, down 1. So as you can see, that is what your new graph is going to look like. So you can, if you choose, you can choose to graph this by using only the parent function and then changing it by your h and your k, which is what I just did. Or you can put it in your calculator. This will get you a really good answer without any problems. You just have to remember that you have to do the powers. If you put it in your calculator, you would have to make sure that your exponent, all of this, the x plus 2, stays in an exponent form, because it will change what your graph looks like. And if you choose to do it in your calculator, you would not have to show your parent function unless they want you to compare it. So that's what the graph looks like. The blue, and I'll put, the blue is my 2 times 3 to the x plus 2 minus 1. Now what we have to do is look at the domain and the range. The domain, as you can see, I have an arrow pointing to the left and I have an arrow that is going up. As it's going up, it's moving right. And so my domain would be all real numbers. And my range, again, as you see right here, is getting closer and closer and closer to my 0, but it does not touch my 0. No matter how far I go to the left, it's never going to completely touch my 0. And so therefore I can say my range is y is greater than 0. So we have graphed 2 times 3 to the x plus 2 power minus 1, and we stated the domain and the range. Last concept that we want to talk about under the exponential growth functions is compound interest. The formula you're going to use with compound interest is A equals P times 1 plus R over N to the nt power. One thing that you need to know is what those letters represent. So the P is your principal, the R is the rate, which is like the interest. N is how many times per year, which is it annually, which is 1 time a year? Is it biannually, which is 2 times a year? Is it quarterly, which is going to be 4 times a year, or is it monthly, which is going to be 12 times a year? And then T is by the number of years. So we have a problem. It says you deposit $3,000 in an account that pays 3.12% interest compounded monthly. Find the balance after 2 years. So what I'm going to do is I'm going to set it up in my formula that I have. My principal. So I have A equals the principal, which was $3,000, times 1 plus my rate, which is the 3.12. But when you look at the rate, your 3.12, when you want to use it, you actually have to get rid of the percentage sign. You have to move your decimal place 2 times. So it's actually, how I'm going to list it as 0.0312 over how many times a year, which it says monthly. So that's going to be over 12. And then I'm going to use NT, which is monthly times 2. Now I've set it up. Now I want to start working the problem. One thing I can do is I can go ahead and combine my power. So I'm going to go A equals 3,000 times 1 plus 0.0312 divided by 12 to the 24th power. Now, more than anything, what I need to do now is figure out what 0.0312 divided by 12 is. And so I'm going to do that right here. And I'm going to say 12 divided by 0.0312. Well, that gives me 0.00 because I can't go into 12. And then I can't go into 3. But I can go into 31. There are 2 12s in 31. So 2 times 2 is 4, and then 2 times 1 is 2. So 31 minus 24 gives me 7, and I bring down my 2. So 72 divided by 12 gives me 6. Now what I can do is I can come back over and I can say A equals 3,000, and I can replace this with 1 plus 0.0026 to the 24th power. The next thing you want to do is go ahead and combine our 1 plus our decimal. So A equals 3,000 times 1.0026 to the 24th power. To save time and space, because I don't have enough room on my board, I'm going to go ahead and get my calculator. And in my calculator, I'm going to go ahead and only do this part right here, the part that's attached to the exponent. So I'm going to type in 1.0026, and I'm going to use my caret, and I'm going to put to the 24th power. And then I'm going to hit enter. It gives me that I now have 3,000 times 1.064301,824. Now, from there, you multiply that by 3,000. So I'm going to come over to this side, and I'm going to do 1.064301,824, and I'm going to multiply that by 3,000. We know that normally in a regular multiplication problem, we would have, because there are 4 numbers here, I would have 4 rows. However, because 3 of them are zeros, I can focus on the 3 times all the numbers. So I'm going to do that now. 3 times 4 is 12, carry the 1. 3 times 2 is 6, add my 1, which is 7. 3 times 8 is 24, carry my 2. 3 times 1 is 3, plus 2 gives me 5. 3 times 0 is 0. 3 times 3 is 9. 3 times 4 is 12, carry my 1. 3 times 6 is 18, plus 1 is 19, carry my 1. 3 times 0 is 0, but add 1 gives me 1. And then 3 times 1 gives me 3. But I have to remember that I have 1, 2, 3 zeros. So 1, 2, 3. Now what I want to do is I need to count how many decimal places I have. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to start right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's where my new decimal place is. So I can say that my A is equal to 3,192, and I want to round this 5 up, and so I'm going to say 0.91. And that is my answer for my compounded interest. Now keep in mind that again, I did almost all of this by hand. I did go ahead and use the calculator when I was doing the 24th power, but everything else I just showed by hand. But if you chose to, and if you have a calculator that can do this kind of math, which is a scientific calculator, you can easily put this equation in at the very beginning and you would not have to worry about all the steps. But I prefer to do most of my stuff by hand if I can, because that way I know I've done everything to the best of my ability.